All right, today we're going to talk about how to utilize the stuff we know about right triangle trig, like SOHCAHTOA, Pythagorean theorem, special right triangles, to solve word problems that would require right triangle trig. Okay, so we're going to talk about two different types of angles that might be referred to. One is called the angle of elevation. Okay, the angle of elevation is an angle from a line parallel to the ground or horizon upwards. Sometimes you can think of this as eye level upwards as well. So here's the line that would be, say, parallel to the ground, and it's the angle going up from there. So maybe this person is looking up at an object or another person. That would be the angle of elevation they're looking at. Okay, the other one we're going to talk about is called the angle of depression. Okay, the angle of depression is the exact opposite. It's an angle from a line parallel to the ground or horizon downwards or down. So say we have a person here, from their eye level or line parallel to the ground, the angle they're looking down at the other person would be referred to as the angle of depression. So going down, angle of depression, going up, angle of elevation. Okay, note, if you remember from geometry, that if we have these parallel lines here cut by a transversal, that these would be called alternate interior angles. They alternate sides of our transversal and they're both in the interior. And you might remember that those angles are equal. So in fact, the angle of depression and angle of elevation of a figure, like these people looking back and forth at each other, end up being the same measurement. So those angles would be the same. Okay, so that's a little extra side note there. So here are the steps we're going to use when we work with our word problems. One, we want to read through the problem carefully and draw a figure, which will be some form of a right triangle, but we need to label things. I like to draw, be a little artsy with these, it's a little more fun. Figure out which trig function to use. So SOHCAHTOA, we'll think about that based on the things that we know and what we're trying to solve for. And then 3, set up and solve our equation, of course. Okay, so those are the steps again. And let's do our first example. To meet safety requirements, a 22-foot long ladder must make an angle of elevation of 75 degrees with the ground. Okay, so we've got some things already. It's talking about a ladder must make an angle with the ground. In this particular problem, probably could have been a little clearer, but we're going to have our ladder here, I think, leaning up against the building or a wall. So say here's my ladder, right? And here is my wall. Right, maybe it's a brick wall or something, so we got some alternating kind of bricks here. All right, and our 22-foot long ladder probably needs to be a little longer to get to the ground here, and here would be, say, my ground. So the 22-foot long ladder, that's how long the ladder is here, must make an angle of elevation of 75 degrees with the ground. So from the ground upwards, this angle is 75 degrees. Now, a couple things we need to be able to assume. Buildings, things like that, and the ground should be making 90-degree angles. They should be perpendicular. Okay, so it's not the leaning wall like I've kind of drawn here. We'll pretend it's a nice right angle. How far from the base of the wall, so here's the base of the wall, should the base of the ladder be placed? Okay, well, here's the base of the ladder. So essentially, what's this distance? That's what we want to figure out. Okay, so we really have a right triangle, and I'm going to just redraw it outside the figure here for a second. Okay, so here's our figure. We just took out the label of feet and kind of the right triangle that we're looking at over there. So remember, when they give you an angle that's not a right angle, that's our reference angle. So we're going to mark that, and we're going to label our 3 sides opposite, adjacent, hypotenuse. So opposite the right angle, that is our hypotenuse. Opposite my angle over here would be the opposite side. And x is the adjacent side, meaning the one next to our angle that's not the hypotenuse. So in this case, we can kind of see the opposite's not very helpful. It's not the side we want to solve for, and it's not the side we know. So now when I'm thinking SOHCAHTOA, which one uses the hypotenuse and adjacent. Hypotenuse and adjacent is ca or cosine. So we're going to use cosine to set up our equation. The cosine of our angle, 75 degrees, equals the adjacent side, remember AH, adjacent, which is x, over the hypotenuse, which is 22. Okay, so then what we would do with these problems is we place this over 1, and we're going to cross multiply. We're going to change it to a proportion problem. So we're going to cross multiply here. So we do x times 1, which is just x, equals 22 times the cosine of 75 degrees. And this is what we need to plug into the calculator to find our length of x, and we need to round it to the nearest tenth of a foot, so 1 decimal place out. Okay, so we go to Desmos, we type in our trig function 22 times the cosine of 75, and make sure your calculator is in degree mode. You should be able to see DEG somewhere on your screen if you're using a different calculator. And it tells us it needs to be placed about 5.7. Remember, if we're going to the nearest tenth, we look one more digit out, and if that digit's a 5 or bigger, we round up. Otherwise, we leave it the same. So here we do need to round up to 5.7. So how far does it need to be placed from the base? 5.7 feet. All right, not too bad. Sometimes it does help, if your figure gets a little messy like mine did here, to just redraw it, right? Okay, example 2. From the top of a cliff 100 meters high. Ooh, we got someone up on a cliff. Okay, so here's my cliff. Okay, so here's my cliff. A person whose eyes are 2 meters off the ground. So let's see, this is 100 meters. And someone's standing here. Well, not with their head on the ground. Okay, so someone's standing here. And it looks like their eyes are 2 more meters off the ground. Okay? Can see their house, which is 600 meters from the base of the cliff. Okay, so if we went this way, 600 meters, their house is somewhere over here. Okay, probably closer to the ground, but you get the idea. All right, so here's their house. What is the angle of depression from their eyes to the house to the nearest tenth of the degree? So from their eyes, remember, angle of depression is from parallel to the ground downwards. And so we'll say they're looking at, right where this hits the ground of their tree. So this angle is the angle of depression. Now, you could go about this in 2 ways. You could actually drop this down and make your right triangle here, kind of in the top right. Or you could remember what we said in the beginning. Remember that the angle of depression and angle of elevation are the same. So if you think about the house looking back at the person, which is a weird idea, but that these angles are actually the same. So if you want, you could make your right triangle here, and finding this angle is going to be the same as the angle of depression. They are equal. So I kind of like the triangle on the left. It's up to you. I am going to redraw this over here on the right for a second. Okay, so note that actually the distance off the ground this person's eyes are really 100 plus 2, right? That's our total distance. So it's actually 102 meters up to the top of our triangle here. It's 600 meters all the way along, and this angle of elevation, which is the same as the angle of depression, is what we're solving for. So again, that's our reference angle if you're solving for the angle, and we're going to label our 3 sides. So opposite the 90-degree angle is the hypotenuse. Opposite my angle is the opposite side. And down here would be the adjacent side. So in this case, the hypotenuse doesn't really offer us any value, right? It's not the side we know, and we don't know it. We could use Pythagorean theorem and solve for it, but that's not necessary. Instead, we're given the O and the A. So we go back to thinking SOHCAHTOA. And in this case, the one that uses the opposite and adjacent is TOA, or tangent. So we're going to set up our equation. The tangent of our angle, which is x degrees, equals the opposite side, remember OA, opposite 102, over the adjacent, which is 600. And remember we said to get x out of tangent, here's where we do the inverse tangent of both sides. So we do the inverse tangent of both sides. And what's happening here on the left, what's happening on the left is that the inverse tangent is going to cancel out tangent. So the inverse tangent cancels out tangent. We get x out of there, x degrees, equals the inverse tangent of 102 over 600. And so now we'll need to go to our calculator, and we're going to also go to the nearest tenth of a degree. Okay, so remember, if you're using the inverse, specifically with Desmos, you need to go to Functions, little Function tab, and then Inverse Tangent. 102 divided by 600. Again, make sure your calculator's in degree mode, or it's going to think it's in radians and give you an incorrect answer. So we're going to one decimal place. This 4, the next digit out, means we do not need to round up, and so we're going to leave it at 9.6. Wow, very, very thin angle there. 9.6 degrees. X is about 9.6 degrees. So that is our angle of depression. Okay, so we're going to do a lot more in class, but we do have one more thing to add into our video. So one of these lessons we needed to throw these in, and this was a good time because this one's particularly short for notes. So the last thing we're going to talk about are what's called the reciprocal trig functions. So think about what we just talked about. We know SO, CA, TOA, right? Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Well, we have some functions that are the reciprocals. So instead of, like say here, sine being the opposite over the hypotenuse, remember, reciprocal means to flip your fraction upside down. If we wanted to do the hypotenuse over the opposite, the reciprocal, so this is 1 over sine, right? Think sine over 1, its reciprocal would be 1 over sine. That has its own trig function called cosecant. Cosecant. And because COS was already taken, it's abbreviated with CSC instead, cosecant. Right, COS is reserved for cosine already, but that's pronounced cosecant. Now, if we want to do the reciprocal of cosine, again, that is 1 over cosine, right? If you flip that upside down, or if you flipped the A and H upside down, we'd get hypotenuse over adjacent. This is referred to as the secant, okay, or SEC for short. And that's the reciprocal of cosine. So these sound backwards. There is a good reason for it, but just know the reciprocal of sine is cosecant. The reciprocal of cosine is secant. So they seem a little backwards. You just gotta have to memorize that for now. The last one, of course, tangent. The reciprocal would be 1 over tangent, and instead of opposite over adjacent, it's adjacent over opposite. And COT stands for cotangent. So the reciprocal of tangent is cotangent, COT. Okay, so we're not going to do a whole lot with these right now, but we do need to introduce them. We'll use them a little bit more next chapter or later in this chapter. All right, that's it for now. We'll do lots more word problem questions in class. Make sure you ask questions if you're confused.